Hello and welcome everyone to today's workshop on speeding up your application release cycle with DevOps and Kubernetes. Thank you for joining us. My name is Tara Van Cleve, and I am a marketing event manager for the developer initiative here at Oracle. Today, we're excited to show you firsthand the benefits of fully automated app delivery in the cloud using a microservice app and migrating it to a DevOps pipeline. We'll also be recording the session, so if you'd like to try the workshop out at your own pace after the event, we will be sending the replay out via the same email you registered with for the event today. If you have any questions during the workshop, please drop them in the Zoom chat and Q&A areas, and we'll be ready to help answer them. We've also set up a channel in our developer public Slack called Workshop December 5th, abbreviated DevOps Kubernetes, that you can access at the QR code or at bit.ly/odevrel_Slack. We'll leave that channel open after the event to contact us directly with any questions and to share resources and upcoming events with you as well. So today's workshop will be presented by Wojciech Pluta, Principal Staff Developer, and Eli Schilling, Developer Advocate. And before I hand it over to Wojciech to get us started, here is the lab guide to follow along with the demonstration today. So I will leave this up for just a few moments and I will drop it in the chat next. All right, so with that, I will turn it over to Wojciech.
Thank you, Tara. Hello, everyone. Nice to see you here. Together with Eli, we decided to do a Christmas special attire. So hopefully, we can take you through the agenda today. So for the overall sections that we're going to cover, we're going to talk about the Save the Wildlife, which is essentially a branded version of the application that we built. We're going to follow it up with the overview of OCI DevOps service, and Eli is going to take us through some of the key benefits and key information through that. Then we're going to follow it on with regards to actually talking about the actual game. It's a multiplayer game, and how we can automate it and deploy it through the various steps that we put together for you as part of the overall hands-on lab experience. And then we're going to wrap it up and answer any questions that you may have. So I just wanted to make a call out for Victor Martin, who has been with us on the journey of building this workshop. He's unwell today, so unfortunately he couldn't join the session, but we hope he's going to get better soon. So my name is Wojciech Pluta. I'm part of the developer advocacy team at Oracle, and my domain is all about application development. And I'm joined by my colleague, Eli. Eli, do you want to do a little intro?
Yeah, good day, everybody. Thanks for having me here, Wojciech. I am a developer advocate in the cloud native and DevOps space. Infrastructure and application automation is pretty near and dear to my heart. Been playing in the DevOps space, not only from a tooling, but also a culture and methodology perspective for close to a decade now. So looking to have some fun today, and thanks everybody for joining us.
Awesome. Thank you very much. So Save the Wildlife, right? So it started as this little concept with regards to we were thinking of how we can gamify experience of learning. And as you can see, it started from this a top-down view that was early days of the development, and moved into this a bit, I guess, nicer looking. I hope you appreciate that. A game that has a whole bunch of different services communicating with each other, essentially allowing this multi-user experience. So we try to build it in a way that if any of you in this session would like to sort of take the underlying infrastructure and actually do something nicer from the front-end perspective, you will be equipped to take it to the next level. And hopefully the underlying infrastructure will be allowing us to actually for you to take it to the next level. The concept of the game logic that we developed is pretty straightforward. So we have a time-bound a session that is essentially all about picking objects that are split between the two types. So one of them is classified as trash, which essentially is you're supposed to collect and essentially save the wildlife, as the name entails. So the other type of objects that we have present is that tagged as wildlife, and essentially those meshes, when they're being collected, gonna end up in point deductions. So we have the time, we have the score, and at the end of each of the sort of game over function, we writing that score into the database and keeping a very simple leaderboard. So this is where it can probably go horribly wrong, but I'm gonna test it because I can see the attendance is pretty solid. So I'm quite curious to actually test how the experience gonna work. So I just posted in the chat a URL of the deployed app, and hopefully we will be able to join and have a little session as you all join in. And thank you, Eli. And hopefully we gonna have a little multiplayer game. So yeah.
Wojciech, maybe while we're waiting for folks to join, you could just give a quick kind of run through about the iteration, right? So you showed two very contrasting examples of the game. It's not like we went from version 1 to version 2 overnight. Like there was a lot of iteration, and
oh yeah,
kind of what we're talking about today is really the evolution of that application in a way that we focus on the code, we focus on game design, not so much on how we're building each time and running through any sort of manual steps to integrate and test and deploy. That's all offloaded thanks to some of the tooling we're going to chat about.
Yeah, absolutely. So the iterative process of the game, moving from top down into sort of the back facing. So we definitely spent a fair bit of time in terms of even implementing the shaders that you can see and all the different sort of solutions that we baked in terms of even how we managing the score and so on. So that was definitely a journey of trying to think, what's the best approach that we can do in order to actually, deliver this as seamless and as scalable as possible. And then we also went through a different deployment times in terms of the testing. So we built some of the versions running container instances or VMs, and then ultimately ending up on the Kubernetes, as this is something that we wanted to really sort of play with and achieve from the scalability perspective and so on. So yeah, there's definitely a process. I think overall probably around 8 months in making in terms of going back and forward. We settled on the front end relatively quickly, but then we had some sort of fine tuning around the back end. So I can see a lot of boats, and the game is still running, which is pretty slick. So I am definitely getting a nice score. So as more players are joining in, more objects are being spawned. So the more people are joining there, you can see more and more things to be picked up. There's probably some lighting issue that probably need to be addressed in terms of some of the lights probably spawning as well as the players. So yes, definitely a few things, but overall the server and the application managed to hold together, which is quite nice. So hopefully we're going to capture some nice scores in the back end giveaway. But yes, the journey of the deployment was definitely a bit of an experience, and we learned a fair bit of stuff. Okay, so moving on with the presentation. In terms of the front end that we're using, so we're using this open source JavaScript 3D library called Three.js. It's a very popular toolkit that is present in and used in a variety of web-based games and applications itself. It is quite heavily supported by the communities, and general construct of it allows us to bind objects, create scenes, cameras, and then essentially add animations and different materials and so on to it, which is quite powerful. And there's a lot of different versions of and sort of things that have been built on top of it, like A-Frame for more kind of VR deployments. One thing worth mention is as well that there is it's supporting the web GPU, which is the modern API for accessing the capabilities of your local GPU in web apps. So essentially what that means that over time, it's going to probably become even better in terms of the graphic performance that it's going to show. So that's why it's kind of trying to future-proof a little bit of, you know, the baseline. You can actually repurpose the front end and use other frameworks like Babylon or Godot perhaps and so on. So at the moment, we only focus on Free.js. So in terms of the Oracle itself, so to those of you that don't know, we offer a full complete cloud solution with flexible infrastructure that enables you to scale and deploy reliable, secure, and performance solutions. It is, in my opinion, an innovative developer platform that has unique capabilities for our own products like Java and Growl, but also, as you can see, it supports open source languages, frameworks, and tools, right? So things like Free.js that we just saw, right? And there's a whole bunch of integration solutions allowing you to integrate your services and workloads. We also obviously have our state-of-the-art database technologies with autonomous database that we used in this example to capture the score details, as well as our newest sort of one of the newest releases in terms of MySQL HeatWave that can deploy any application that can meet your business requirements. That coupled with some of our low-code platforms, Apex and so on, essentially allows you to have this one-stop shop in terms of running your services that you like. We're building and adding more AI capabilities at every layer that allows you to build programmatic intelligence into workloads and applications based on your needs. We have also a whole bunch of the observability and security related capabilities that we probably could use a whole another sessions to cover. In terms of overall regions, we have acquired a few data centers that we deployed, allowing you, when you're deploying your applications to have them closer to your users, and through the automation like DevOps and so on, you can manage and spin up and spin down services as you deem to see fit. Eli, over to you, sir.
Excellent. Thank you. So, before we kind of get into the tooling itself, it's really important to start by just approaching a consistent understanding of DevOps and the fact that, we have this sort of continuous process. It's a collection of people, process, and technology, as I'd like to say, where we kind of adjust our culture to align with a set of practices and a collection of tools to continuously improve our software delivery process, to accelerate our delivery process, to improve how we, code, integrate, test, deploy, and secure our application ecosystem. And, part of that, we kind of take a step back and think about, well, why do we do this? Why do we bother? There's really a couple of key tenets in the DevOps methodology, one of which is being able to fail fast. The better we get at iterating, the faster we can go to learn what works and what doesn't, the more quickly we can iterate and deliver functional capabilities to our customers and our end users. The other piece of this is about mitigating risks. So whether that's utilizing security controls, whether that's implementing automated approvals, automated infrastructure provisioning, things that, I'll just be blunt, remove the human element from our software delivery, our software supply chain, if you will. Accidents happen. We all know we're only human, but the more we can do to generate this automated software supply chain, the better we get at delivering fully functional and efficient code and applications to our customers and our end users. So the OCI DevOps service is really modeled around those tenets that we talked about, kind of aligning the tools with the process, with the methodology, providing the ability to increase reliability, reduce or mitigate the potential for issues by automating as much as possible. So this continuous integration, continuous delivery, continuous deployment, we're trying to automate that end to end as easily as possible to give you the ability, the mechanisms to continuously test, deploy, evaluate, and enhance our underlying code base. We provide with that a layer of security to, again, integrate with existing features like identity and access management, Cloud Guard for compliance and security controls, security zones, container scanning, other things like that we basically just plug those into the pipeline, and now we have additional tools that are available to continuously enhance our code base. And then, of course, governance. We need to be able to track what is happening, what's successful, what's not successful, kind of implementing that feedback loop to enable our developers to quickly identify and understand where things are going right, where things are maybe not going right, so we can implement changes, make adjustments, and deliver updated code, updated artifacts as quickly and efficiently as possible. Now, as far as the continuous integration portion of this, and we'll just say from the entire perspective here, the DevOps tool it's a serverless function. The backend system is going to take care of executing all of that on our behalf and basically streamline that process from start to finish. The DevOps tool, it's built into the platform. It's integrated with the rest of the OCI ecosystem. So from a security perspective, being able to allocate permissions, not only for the pipelines to execute tasks on your behalf, but also defining what users can and cannot do within that DevOps tool chain. And also from a just an overall platform integration perspective, how we're collecting the source code, how we are building, integrating, testing, delivering, and then also eventually deploying, which we'll look at. So kind of the end-to-end process here is, the continuous integration and delivery, where we are essentially committing our code to a source control code repository. That is potentially going to trigger the build pipeline, which will collect the source code, perform any build tasks, like if we're running Node, if we're using a compiler, or if it's just something like Python, where we're going to aggregate that into an archive file for delivery. Whatever that build looks like, testing those artifacts to make sure that they are going to be instantiated properly, that they are going to be functional, not lacking in dependencies or any other required frameworks. And once we know that's a good functional artifact, we can deliver that to a registry of sorts, whether that's the OCI container registry or the artifact registry, if we're talking binaries or other deliverables. Or not represented on the slide here, but even out external registries. So it again, not necessarily requiring a complete supplantation of all your existing tools. We want to try to make sure we can integrate with and utilize existing tools and processes that we simply lay over the top of this toolkit here. So if we dig into the pipeline, the build pipeline a little bit further, this is just a representation of the user interface. And you can see here, we basically utilize a build runner, if you will. And there's a couple options here. We can define it, select a default shape or a custom shape. And in this instance, basically the only thing you're paying for with DevOps is this build runner for the number of seconds that it's up and running to actually build and deliver your artifact. And it's nice to have the flexibility here to pick how much CPU, how much memory, and then also the underlying container image, depending upon what application you're building and what OS level dependencies you might have. Now, on the deployment side of things, right, we've checked in our code, we've triggered the build process, we've done some basic validation testing, generated an artifact and delivered it to our artifact repository. Now it's time to figure out how we are going to release that into the wild, if you will. So we don't just want to take that artifact and jam it into production and walk away. That's a recipe for disaster. So let's think about how we could do this in a way that minimizes or mitigates, again, potential risk. That's kind of what we're hoping to accomplish here with our DevOps practice. So the continuous deployment piece of this pipeline gives you a variety of release strategies. We'll take a look at those in a couple slides here, but basically things like canary deployments, blue-green deployments. How do I want to go about sort of validating this in a quasi-production environment before I just release everything and see what happens? This gives us the ability to integrate with additional workflows. So we'll take a look at a few examples here. But this is an opportunity to implement additional security controls, additional quality controls, if you will, to ensure that we are delivering an effective and efficient product at the end. I do want to just point out really quick, because we're going to be chatting on Thursday, kind of along the same lines here. It's a little bit of a tangent, but from a security and a secure software supply chain perspective, we're going to be chatting with one of our partners, DigiCert, on code signing and jar signing. If that's in scope for you, hopefully you'll come out and join us. We'll dig into the DevOps practice in a very specific manner there as well. But enough about that. I want to jump to the next slide if we could here. And again, we're going to focus on the deployment pipeline. So obviously we want to deploy that artifact or the artifacts we've created to a non-production environment. From there, we're going to run a variety of tests to make sure that it's functional, it's performant, it's doing what we expect it to do. This is a great example if you're doing like test-driven development, right? You can basically derive your tests in conjunction with your code. You know what's going to be tested, validated, and then decide whether or not to pause that deployment for approval, make sure to validate the output of those tests, click the approval button, and then we can deliver that or deploy that latest artifact, that latest code base to production. Nice thing here, again, integration. So when it comes time to deploy to production, we've got direct integrations with compute, so deploying to instance pools, container engine for Kubernetes, you can deploy to OKE, or if you're talking serverless applications, we can use this exact same process for serverless functions in the OCI ecosystem. Now, if we take a look at the next slide, again, this is the deployment pipeline side of things. Blue-green strategy, the canary strategy, incremental deployment through compute instance groups, so kind of a rolling deployment. Again, we don't just want to smash it into production and see what happens. We're going to be very thoughtful about how we roll out this application, how we test and validate before we potentially negatively impact our customer experience. After the deployment process, we have a level of control. So this gives us the option to shift traffic. If we're doing a canary or a blue-green deployment, we can shift a little bit of traffic, see how it goes, shift some more traffic, see how it goes, and then decide where we want to go from there, whether we want to continue and shift everything over like in a blue-green deployment, or maybe we need to roll back and go back to the drawing board because we introduced a feature or some functionality that was unexpected in this particular code base. The integration piece here is really interesting as well. So talking about integration with the rest of the ecosystem, we can execute a serverless function. So think about this as a small set of code that's going to perform a very specific action. That could be to create or alter or update a singular resource in our environment. It could be to increment a configuration in our central code base, or we can use the shell stage, which basically gives you the ability to run shell scripts and various commands to do additional integrations pretty much across the board. So very powerful and feature rich here. Wojciech, I think that puts us on the slide where I'm going to pass it back to you to talk a little bit about this delivery of our actual tangible 3JS application here.
Yes, thank you, Eli. Thanks for this overview and additional context to the service itself that we're using. So overall flow for the hands-on lab that we're gonna take you through the steps in a minute is exactly what Eli said. So we're gonna be able to commit the code. Look at the code and then essentially trigger build pipeline and deployment pipeline essentially, and then in the end ending with this infrastructure that is using Kubernetes and a couple of other services that are sort of supporting and working as part of the deployment. So just talking through the overall application flow. So this is the simplified view in terms of how the currently the network and communication happens. So what we experience during the demo is all of us as players join through the browser, and that then connected and is fronted with the load balancer that essentially determines the type of traffic and then routing that either to the server or web. By inspecting the packets, it's essentially using socket.io and then create a connection to the server and sending the information there. So once the server essentially is the one that does obviously a lot of the heavy lifting. So at the moment, the deployment that we used is actually running on individual one node, one pod per container. So obviously we could scale it up as we deem to see fit. So far, it actually performed okay with all the people joining in. But if there's scalability requirement, then we can certainly increase the number of servers or web front end, so that way we can accommodate more and more players. So there's a web container, we have a server container, and then we have a three other services. So we have Redis container that is essentially managing all the messaging. But the star of the show here is actually our service called Coherence, where it's actually storing a lot of the information about the game states. So it is responsible to managing the time. It is managing the location of all the objects and where the collision happened. And then obviously if the collision happens, it validates whether the object that the collision happened with, was it the trash or wildlife, and then based on that it would increase the score. And then once the time has finished, the server would then use the Spring Boot based application to actually write into the autonomous database to capture the score and the person that is managed to get that score. So it is, like I said, it is a very solid foundation. So if you would like to build something on top of it, another experience, another type of game logic or so, you can totally do that. And then using the lab, you can essentially completely change the front end and using Free.js itself if you didn't see fit. So as you can imagine, there's a lot of networking happening there. So one thing to mention is that there's been some research done in terms of overall traffic costs across the various cloud providers. And we, as Oracle, seem to be the most competitive on the price itself when it comes to network. So obviously, if you're planning to deploy this or rely on this type of heavily communication, then Oracle Cloud is probably the most cost efficient option for you. And we heard that from some of the customers that we're working with and startups and so on, that the pricing that we offer in terms of the network is quite competitive. But enough of the talking about the theory. So with regards to the lab itself, so we released the lab, and we actually the first time we premiered it was during the Cloud World few months ago. So now we obviously releasing it to the public. So what you can do is by signing to the developer.oracle.com/livelabs, you can access a lot of various workshops and hands-on lab itself. And then if you follow either the link that Tara just copied into the chat, what you can find there is the actual workshop details itself. So I think somebody was asking about the prerequisites. There is much more details in the workshop section in terms of what is required, but I guess there's an element of understanding around some of the concepts at the high level. But yeah, through the hands-on content, you will be able to actually interact with the services as you go through different steps. And then to get started, all you have to do is click on the green button and then click on Run on your tenancy, and that way you will be able to access the workshop materials. So very quickly, in terms of the overall hands-on lab content, essentially it's split into the few steps with regards to setting up and deploying the infrastructure and additional components. So first, we took the approach of actually accessing and creating a connection with the GitHub. So a GitHub account will be required for you to do the workshop in full. And then we start essentially by forking the repo and cloning it, and then generating the GitHub token. And that allows us then to have a fully a synchronized version. So if you decide to check in your local changes and commit them, you can just deploy them and pick them up in the Cloud Console directly from there. There is every 60 seconds, there's a process that is syncing essentially the content. So that way you can deploy it and have your own version. We do have a couple of steps that we're running with regards to Terraform and deploying the infrastructure and the DevOps project itself. But once that is completed, which takes something around 20 to 25 minutes, we're deploying the whole infrastructure with regards to OKE, the database, and then the vault and a couple of other bits and pieces that essentially create the whole solution for you. Then everything sort of moves into the UI of the DevOps service, where you can manually start the build pipeline or set up by yourself the trigger, and then deployment pipeline is also then accessible for you. So you can also, we have a step around actually modifying the app and deploying the change in terms of the additional rollout and rollback. And then if you finish with the lab and decide to run a cleanup, you can do that. So I'm going to just run a quick video now, which is about the overall sign up for the video, if you want to do the steps yourself. And then after that, I'm going to dig a little bit deeper in terms of all of the steps.
Hello, I'm Victor Martin from Oracle Cloud. I'm going to walk you through the steps to sign up for an Oracle Cloud free tier. Please follow along. Oracle Cloud free tier gives you a set of always free services. These services will be available forever: 2 autonomous databases, 2 virtual machines, and up to 4 ARM processors virtual machines. You will also have a load balancer, block storage, object storage, and much more. As part of your Oracle Cloud free tier, you will also have a 30 days trial with free credits for other services like analytics or Kubernetes. Sounds good, isn't it? Are you signing up for a workshop or webinar with us? Please ensure that you sign up with the email you use for the registration of the event, and check if we have activated the special promo. Oracle Cloud will never charge your credit card, even if the credit card is required for verification purposes. To be a paid account, you have to ask Oracle Cloud to do so explicitly. Let's dive in. You need to add your country and your first and last name. Oracle Cloud will check you are a human by asking you to resolve an easy challenge. Click Verify my email to move to the next step. If your email has been activated for the special promo, you will see this pop-up window. Select Offer to continue. Otherwise, continue with the sign-up process. Oracle Cloud will email you to verify your address is correct. Check your email and follow the link in the email. On the next screen, you will fill in the password. Make sure you comply with the strong password pattern. Confirm the password by typing the password again. Fill in the cloud account name. It is a unique identifier for your account. Select one that is not taken. You can only use one region on the free tier. Select the home region where you want to get started. Select one geographically close to you if you are not sure. At the bottom, click Continue. Fill in the address information and phone number and click Continue. The final step is to accept the agreement and click Start my free trial. Oracle Cloud will start provisioning your account. This process takes a few minutes. During the next few minutes, check your email and you will receive an email with a sign-in link. You will need to use a two-factor authentication for Oracle Cloud. Select Mobile and install the Oracle Mobile Authenticator app. Add a new account on the mobile application by scanning the QR code. And finally, the phone will be successfully enrolled. You can sign in now with the same credentials you used before and the two-factor authentication. Welcome to the Oracle Cloud Web Console. Go to the menu to explore all the services available on Oracle Cloud. You can also search for the services you are interested in. On the right side, you will see the home region. The next icon is for Cloud Shell, a small free Linux instance with many tools pre-install and configure, for example OCI CLI and languages like Java, Python, Node, and more. Close Cloud Shell and explore the code editor. You won't need to install anything locally to start working with Oracle Cloud. On the Help icon, you can find documentation links, create support requests, and request a limit increase. You are all set up to enjoy your new Oracle Cloud account. Happy hacking!
Okay. So let's now go through some of the steps of the lab itself in a bit more details. So as I said to you, the lab one is all about setting up the fork of your repo, creating an access token, and then cloning the new repository. Lab 2 is about setting up foundational infrastructure using Terraform. So you apply that and deploy it. So as I mentioned earlier, we can deploy Kubernetes cluster, notification service, vault, master key, and secrets, policies, and dynamic groups. So there is a fair bit of the config that you can potentially change and actually see how the things are being deployed. So that's quite nice. There is then a couple of steps that we execute as part of the Terraform within the Cloud Shell. That is actually much faster than that. And then the build pipeline is where we start to deliver the artifacts and containerization of our application starts. Then the deployment pipeline is executed. And then when you want to actually bump the version of a service or roll out or roll back up features, then you can do it that way too. If you decide for some reason to destroy and revert back, then you can just follow some of the steps there. So let me now open the GitHub repo. So once you actually once you actually access the live lab section, so this is what you can expect. So so as I said to you, there are a couple of steps in terms of how you can actually go through the forking the repo, and then how you can create your own local version for you to start working on it. To actually access it, we're going to create an access token that we then going to populate in the app during some of the scripts when we're setting up the environment for you. So it has all of the screenshots required. We also embedded the copy button, so to make it as easy for you as possible in terms of following the steps and being able to deploy the solution by yourself whenever you decide to follow the steps of the workshop. So in terms of forking the repos, though, all we're doing is essentially creating a local version that allows you for your deployments, and then as you check it in, it allows you then to release that. In terms of the overall foundational infrastructure, so there's also some videos here at the top that are embedded in terms of the steps and how you can do it, so you can revert to those at any time. But in terms of overall steps here, we have few scripts that are running that are allowing us to set up the environment variables. We can choose the compartment that we want to deploy it in. At that point, we will populate the GitHub token, and then the notification service essentially is there for you to be notified when the deployment is finished. And then we go into our environment folder within our Cloud Shell. Sorry, I did mention that. So so when you actually going through the steps, you can actually click at the top of the Oracle Cloud Console to actually open the Cloud Shell right here. So this is where you can then deploy all of the commands, and that will essentially work through individual environment setup and the steps that are here. Once we do that, we just literally run the Terraform apply, and that, like I said, it's gonna create the Kubernetes cluster, notification, vault, and policy and dynamic groups. You will be able to review them by accessing the UI components, and then as the Terraform completes its work, it's essentially going to give you some links and information that you can use. Then the next bit is the setting up the DevOps project. So this is where we actually build the connection to our repository, and then when we execute the Terraform script, we then able to access that particular project. So then once we go through lab 3, lab 4 is all about working through the UI elements of the DevOps service. So you able to access it in the compartment that you chose, or the root compartment if you decide to use the root one. And then once you go in there, it gets very, very straightforward, because essentially we created a lot of the assets for you. So so you'll find that there's a mirrored GitHub repository. So like I said, that will be checking in for any changes. So every time you're ready to deploy, you can just go there, and those changes, once committed, will be mirrored for you. When you're ready to run your build pipeline, you can go in. You can go into the Terraform, the project itself, and then build pipeline will allow you to start manual build of the project itself. So then you can just literally start manually, and then it's going to take a few minutes to then give you the overall status, and it will tell you once it's done that it built the services and delivered artifacts and so on. Then the deployment pipelines, this is where it gets, we are able to then deploy the final solution. So we actually have built that using Customize, and then somebody raised their hand. Okay. Could be, yeah, sorry, there's a question. Can be a non-GitHub project.com. It could be non-GitHub project. It would probably require a bit of a tweaking, but yes. Okay, so I'm gonna, I don't know. There's nothing coming through. So yeah, so when you run your pipeline, then this is where you're gonna end up with a load balancer address at the end of it. So that is essentially the same address as I shared earlier. Well, it's going to be different for you, but that's allowing you to then, access the front end application, and that way, you can have a connection to the database. The database is going to be deployed in the background as well. So so that way, you have a full-on service. And then we also sort of catered for a basic, I guess, a new feature release. So in this case, we essentially capturing the version of the server, and then you can quickly check in, or either locally or directly in the GitHub, an update that you can commit the change. And then once that change is committed, you can run the build pipeline and then deployment pipeline, and then that way you will have the sort of the new release. So that could be anything. Obviously, it could be something as easy as that, or something a bit more in terms of the models and so on. But hopefully, it gives you a bit of understanding in terms of what can be done. And then, as I mentioned, there's a cleanup script. So if you're doing this as part of your, trial, and then you want to sort of clean it up and delete after, you can also do it by following those steps. Right. So that is the gist. So what I wanted to show you is that a bit of a sort of what I use for the local deployments or local development. So I have my my Fort repo cloned locally. So for the development, I essentially am running a Rancher, which has cluster running locally. I've deployed the coherence as a container, so that is running already, and then I can essentially start Redis server as well, and then by quickly cding into server and that's not what I was looking for. npm start, yeah, that's the one. Yeah, so my so now I am running the local version with the 2 containers and a server that is allowing the communication and the WebSockets. And then now I can cd into the web folder, and essentially in there I can run dev, which is going to now deploy my local version of the game, right? So you can see I was sort of messing around with it, and redid the whole thing as a more kind of in the festive spirit with the massive snowman, Grinch, and sleigh instead of the boat, right? So that obviously allows me to fully change, the game, and I still have some of the the game parameters in terms of the deploying the components for me to track, but I can also add some other objects, or even change the type of objects that I want to deploy. So I can do all of that in terms of the front end side of it in my web script.js. So essentially here is like some of the stuff that I did earlier in terms of commenting out and to make the snow version. And but what you can do is either upload your different materials. You can change your models here. So by default, there's a couple of things that we actually added for you. So if you want to mess around, we have for example a model of a turtle and boxes that can replace the trash. Earlier on I created this sort of Grinch model and actually changed the whole water material into the snow. So yeah, that allows you then to play with the code and then change it to your own liking. So all of it in terms of the front end, you can check and change anything there, and that essentially is managing some of the game logic. And then you have some scripts that are around deploying the application. So when you were sort of setting up the coherence and the Redis, there's some scripts that you can use from there. There is the score. There is the server side of it, which has all the information around the communication and of the server and so on. There is the deploy script that has also the information about the DevOps and how to deploy that. We also have another workshop that we're going to run in the new years, which is more about various deployment of options of this. So without the DevOps service, we're going to talk about how to deploy this using the VMs and Kubernetes and how to so it gives you like full control in terms of how you can set up and deploy the app itself. So it gives you a good baseline. I would love for you to go to our GitHub repo and share any sort of PRs in terms of anything that you come up with and change, or maybe add the models or completely redo the front end. It would be great to see what you all come up with as an idea. So we have 4 minutes before the end, so I'm just gonna stop sharing and see if there's any questions.
Well, thank you everyone so much for joining us here today. Yeah, we do have another event coming up this Thursday, and that's on our developer.oracle.com/events page. And then if you want to see the follow-up to this workshop, that will be on January 11th, and that will also be on that same page once it's posted. So thank you again so much for joining us, and we hope to see you at the next one.
Thanks, Wojciech. Thanks, Tara. Thanks, everybody.
Yeah.
Take care.
Thanks.